Good morning, good afternoon, good evening to wherever you're located in the world, and a very warm welcome to our webinar today that goes out to our customers, students, interested engineers, and last but not least to our competition. My name is Stefan Heuser, and I'm your moderator for today's webinar with the title SKAI 3 Low Voltage for Motor Controllers in Forklifts and Industrial Vehicles. So if you have to build a motor controller in the low voltage area below 144 volts, but you would like to focus on what really matters, then the SKAI 3 low voltage will be your solution. It does relieve you from the need to design the complete power part with standard components, but it gives you much higher flexibility than a complete inverter system that would give you. With the SKAI 3 voltage, you can really focus on the motor control by buying a tried and tested power system. Before we get started with the presentation, some words about our webinar platform. In case of any connection issues in the presentation stream or the sound, please try to reconnect using the button on the very top of your browser window. In your browser window on the right-hand side, you see the chat window, which you can actually hide to increase the presentation window. In case you have any comments or difficulties, please let us know via the chat. All messages are private. If you have any questions about the content, please mark your comment as a question with the Q&A mode button. We will try to answer your questions at the end of the presentation, and the questions that we do not manage to answer today will then be answered later by email during the next days. Also, you can send us an email either to webinar@semikron.com now or also after the webinar, and alternatively, you can also reach the presenter directly by email at skai-lv@semikron.com. And finally, we will also share the slides as a PDF file at the very end of the presentation, and you will see the download button for that just below the chat window. Your presenter today is Dr. Lutz Görgens. He's the product manager for the SKAI 3 low voltage at Semikron. Lutz holds a doctorate degree in physics after studying at the University of Bayreuth and the Technical University of Munich, and he focused during his studies on gallium nitride, on GaN technology. Before joining Semikron, he worked for 8 years as a team leader in the semiconductor field, responsible for application engineering and product specifications. And he joined Semikron in 2011 and has been since solely responsible for the low voltage SKAI products. So enjoy the webinar. Lutz, the floor is yours.
Thank you, Stefan, for the kind introduction. Also from my side, welcome everybody to my webinar, SKAI 3 Low Voltage for Motor Controllers in Forklifts and Industrial Vehicles. What will be the webinar today? After a brief introduction on Semikron, I will directly enter the main part of the webinar and explain you the idea behind the unique SKAI 3 Low Voltage and what are the benefits you get from this new concept. After that, I will show you how that product idea is implemented and how to work with it. In the part Technology, Ruggedness and Performance, I should show you the basic technologies used in the product and how these affect ruggedness and performance. And last but not least, in the last part, I give you a short glimpse on our new production line built especially for the SKAI 3 low voltage platform. So who is Semikron for those who don't know us? We are a leading power electronics company operating globally with more than 3,000 employees worldwide and have a revenue of about 535 million euros in 2019. Semikron manufactures power electronic products with a wide range of integration, starting from our own diodes and thyristors for discrete devices. Semikron is especially known for power modules, where we actually pack third-party silicon side by side to our own silicon. By adding further electronics, we create products like the stack, where we have power electronics here, drivers here, and overall electronic installation added. The top end of the integration is formed by the product line called systems. Here we can offer to deliver electronic products complete in a box, including the controller and the software. These products are typically strongly customized to meet the requirements coming out of the customer project. The latest addition to the product family is the SKAI 3 low voltage, where the product concept is built around the idea of customizing the product together with the customer. Even though we can offer to design customer-specific controller hardware and software, in this webinar, I want to focus on the version where we offer a SKAI 3 low voltage power platform, which enables the customers to create their own motor controller based on this platform. Even though the SKAI 3 is the latest addition to the portfolio, this does not mean that this kind of product is new to Semikron. In the last 25 years and more, actually, we have delivered more than 1.5 million motor control systems for material handling vehicles, which are almost exclusively used in customized customer-specific products. With the SKAI 3 low voltage, we want to make this technology available now to a wider range of customers, opening up new opportunities and new markets. So what is that SKAI 3 low voltage I'm talking about? Well, very simple. Let's start with what it is not. Well, it's not your regular three-phase low voltage inverter where you can buy a box where everything is inside, motor controller, software, power electronics. You just connect batteries and motor and some levers and off you go. No, the SKAI 3 low voltage is a different concept. The SKAI 3 low voltage tries to help you when you want to build your own motor controller, but you are limited, for example, because the power level you need needs a dedicated power technology, and taking a PCB and adding TOs just won't do it. Or they invest for all the mechanical design, the cooling plate, the cover, or the power connection is just too high for your project. Or you're simply lacking the production facilities. So you might get a PCB from some EMS, but actually getting the whole thing assembled is a different story. Or you don't just have the time to do everything on your own. So any of these questions apply to you, but you still want to have a motor controller which you would consider your own design, then the SKAI 3 low voltage might actually be a solution. By adding your controller and your software to the SKAI 3 low voltage power platform will help you create your own motor control unit with optimized functionality and fastest time to market. So what is SKAI 3 low voltage then? Well, the SKAI 3 low voltage is an easy to use power platform for MOSFET inverters. It includes already a complete electromechanical design. So you have a housing, you have power connectors, you have a cooling plate, you have all the important components like capacitors, power switches, three-phase system, a gate driver. And to make it convenient, we designed the gate driver in a way that it's very easy to connect. Then the power section is of very high performance, and we come to that on the technology part. How is that possible? And last but not least, we have a dedicated production line where this unit is manufactured. So the specification, where did we take the specification from? The specification for the SKAI 3 low voltage is largely derived from requirements coming from forklift applications. This, however, does not mean that the SKAI 3 low voltage is limited to this application field. The tough requirements from the forklift trucks make the SKAI 3 low voltage fit to be used in any low voltage application. And with the power platform design concept, it can be even adjusted to complex products or very specialized very specialized products like they are required in micro EVs or even passenger cars. So whenever you have the requirement for a MOSFET-based inverter system, being it industrial type or off-road type vehicles here, or even more complex on-road types like on the right side, the SKAI 3 low voltage is probably the right platform for you to design your own product. So what are these requirements now that come from the forklift? Well, forklifts have a long operating lifetime and they are used under harsh environmental conditions. So they're used in cold store, so we need to start from minus 40 degrees C operating temperature up to 85 degrees C when the forklift actually stands in the open sun in some hot country. So we have very harsh temperature ranges, and we need to fulfill still 20,000 hours of operation with that inverter. So lifetime requirements are extremely high. At the same time, the inverter must be able to handle very high shock. You can imagine easily with a forklift truck being a massive piece of iron going across a rail, the whole system shakes because there's just no significant shock absorbing system installed, or the fork hitting some wall. There's always a lot of shocks going through the whole system. So high ruggedness for shock and vibration is a key element in the design of that inverter. And last but not least, we need an IP rating which makes it useful for outdoor operation. When you look in the history of forklifts, you see that electric forklifts in the past have been used mainly in indoor applications. So IP rating was not so much of a concern. But now more and more combustion engines get taken away and are replaced by electric engine trucks. So also the whole truck and especially the inverter has to be able to cope with water. So IP66 is what we need at least for outdoor operation of the forklift trucks. To give you some very basic idea on the power requirements, just here for two standard products, one would be the 48 volt battery type with using a 100 volt MOSFET inside, or the other type would be 80 volt rated using a 150 volt MOSFET. These are the two standard versions. Others are available on request. So how much power can you get? So nominal output current, that means really continuous current using an air-cooled system for an infinite amount of time. We are about 230, 240 amperes RMS as an three-phase output. Under overload conditions, so going up a ramp or a hill or doing extra heavy load driving for a shorter distance, the 2-minute rating is well above 400 amps, 410, 420 amps, depending which unit you're using. Of course, these values depend strongly on the detailed operating conditions. The ratings here are given for an ambient temperature of 40 degrees C and air cooling. If you consider a water cooling system, different values, of course, will come out. These currents come from a box as small as 140 by 150 by 81 millimeters, so well below 2 liters of volume, generate you an output current in overload above 400 amps. And the whole enclosure is nicely fitted with an IP66 protection for the electronics inside. Of course, outside contacts are not protected. So if you need protection on the power connections, you have to think about either putting them into an enclosure or generating extra cover for that. But that's something, of course, you can decide for which application you use it. So on the electromechanical design, how is that concept built? How can it be flexible enough and convenient enough to be used for anyone as a platform? So let's start again with a product idea. You already have a motor control unit, or you know how to do a motor control unit, and you want to turn your motor control unit on a PCB into a complete motor controller. And as mentioned before, you can either do your own design, then you start picking MOSFETs, you start picking capacitors, you are looking for a power electronic system, and then you have to add your cooler and all the mechanics that hold the system together. So you're putting together bit by bit the whole thing, and you really simply do really everything on your own. The alternative to that is take a SKAI 3 low voltage, which is completely developed, having a top performance, is fully qualified as it is fully assembled and 100% tested on a production line. You just add your one PCB to the SKAI 3 low voltage and you're settled. So it's really that easy. You see, you create a PCB as shown here on the top, which has a certain size. There's a clear specification, what are the dimensions, and then it will fit under the cover, and that's all you need to do. And it's really that simple. Step one, you take your PCB that you have created, you put it in the cover. Step two, you fix the PCB with the screws in the predefined positions. Step three, you put the cover with the inserted PCB back on the SKAI 3 low voltage. You fix the cover with the screws, you add the sealings on the power connectors, and that's it. No cables, no loose parts, very simple to do in your own manufacturing line, completing a SKAI 3 low voltage and create your own motor controller in your own facilities. Of course, if you don't want to do it yourself, there's always the option that based on a customization project, we can work together and Semikron can offer to actually do the full assembly and test as an inline process on our production line. So if you're interested in that, just contact us. So how can the control board and the gate driver board actually fit so nicely into each other? The design is very simple. So the control board here, which is actually mounted in the cover, but it's not shown here, is fitted with two 20-pin connector systems, which of course match the counterparts on the gate driver. And we have chosen a special connector type, which has a very large acceptance in a very large tolerance. So by putting the cover on and using the guiding pins that are installed in the cover and on the power system, these connectors will automatically meet and go into a stable and fixed position as long as the cover is positioned and mounted. And then the next step for convenience, of course, is also important, is that we also need the electrical and the mechanical interface to be similar. So the controller PCB or the controller should be easier for the controller to actually talk to the gate driver. And for that, we actually made sure that the electrical and the mechanical interface are matched to make the design of the controller as easy as possible. So the first connector actually forms the signal for all the control signals. So these include the 6 gate driver and protection functions. We have some channels for error management, and then the voltage measurements for all the individual phases and voltages. On the second connector, we handle the current measurements and the temperature measurement. These sensing elements have already some kind of isolation on their own. So by making sure that the gate driver has actually an isolation between these two areas, and also the connectors have the same isolation between each other, we make sure that you don't need to put extra isolation between parts that are already isolated before. So let me summarize here for the electromechanical design. So just by simply adding your controller and software to the SKAI 3, you immediately get your complete motor controller system. And the electrical interface, the mechanical and the electrical interface is optimized for easy incorporation of your controller. A few words on technology, ruggedness, and performance. So as I said in the beginning, Semikron does a lot of power modules. So we are in the special situation that we have a technology available that is usually not available for MOSFET-based inverters. So coming from all the high power modules, using ceramic-based substrate is the standard for Semikron. And with the SKAI 3 low voltage, you have the opportunity to use a ceramic-based power electronic systems with MOSFETs for your solution. And on top of that, of course, you not only get the option to use a ceramic-based substrate for your power system, but you also get all the different assembly technologies used in power systems to get really a high power and high quality MOSFET inverter. So what we use is we use actually bare dies instead of TO packages, which gives us a lot of extra space because we leave away the extra packaging. These chips are standard soldered to the ceramic base, which is an established and convenient process. For bonding the top side of the chip, we use aluminum wire bond technology, again, well proven and perfectly suited for the kind of application we are using. We use what we call the base plate less systems. So for all of you who are a little bit familiar with the power system, power electronic modules, you know very often base plate systems are used where the ceramic is already soldered on a aluminum or copper plate before that is again mounted on a cooler. And with Semikron, what we offer is actually putting the ceramic directly on the cooling system. And that's exactly what we do with the SKAI 3 low voltage. We actually connect the ceramic system directly to the underlying cooling system. And last but not least, we are using pressure contacts. That means all the contacts between DCB and AC bus bars or DC bus bars, all the connectors on the outside from the bus bars to the actually to your cables is all done by pressure contacts. And we have gone even further. We have even made the signal contacts in the system spring contacts or pressure contacts, with the benefit is a pressure contact cannot break, while a solder joint or a welded joint can always tend to weaken after years of operation and may break. A pressure contact is allowed to move under thermal stress, and then that way is basically free of fatigue. So how do we build the SKAI 3 low voltage? We start very simple with a cooling plate as a base structure that may be also an air cooler. This may be a water cooler. Here it's just shown with a simple plate. And we mount the power switches on top. You can't see them right now. They are below that nice protective white foil here shown. And what's already here in the beginning are the connectors, or let's say the mounting posts for the later AC and in between DC connectors. As a second part, we add what we call internally the power core, which is really a fully integrated block taking the power routings for the AC and DC connectors. You see them here coming out on the front side with the DC link capacitors in brown. The current sensors shown here, 3 sensors on the front side in black. Temperature sensor, one is on the ceramic, one is actually on the PCB itself. And the gate driver functionality, which is also part of that PCB. That system is pressed down on the ceramic system, and in that way, using pressure technology, forming all the signals and all the power contacts needed in the system between gate driver, DC link capacitors, AC and DC routings, and the ceramic system. And then in the third step, basically all that is required is the mounting of the control board. So adding the cover and the control board, putting everything down from top to bottom, completes the SKAI 3 low voltage inverter. Mechanical ruggedness, of course, is one thing. However, electrical performance is the other that drives the design of a powerful inverter. The compact integration is not just a nice feature that helps us to reduce size, weight, and material cost. It's a prerequisite to actually low parasitic effects. And low parasitic effects are really the key feature of a MOSFET inverter. Besides the omnipresent ohmic losses in the assembly, for MOSFET-based inverter systems, the parasitic loop inductance is extremely important. With the low voltage values used in the system, overshoots during switching must be kept very low because there's hardly any voltage gap between the MOSFET voltage rating and the battery applied battery voltage. So keeping that overshoot low typically means we have to slow down the switching process. The solution to that is if you minimize the parasitic induction formed by the assembly between the switches and the DC link capacitors, you can minimize the inductive effect and you reduce the overshoots just by themselves, and you can still switch fast with low switching losses without compromising on the switching speed here. So what we do is the following. You can see here a cross section of the SKAI 3 low voltage. Just for your orientation, there's a gate driver standing vertically on the front side. We have the customer controller board here horizontally on the top, and the connection between those two units here on the front. That's our SKAI 3 low voltage. And now on the left side, a basic schematic on what the power section actually is. What we have is inside 3 half bridges formed by the MOSFETs, and they are closed here with the DC link capacitors, which are all paralleled in that system for optimum performance. So that's electrically all the SKAI 3 low voltage actually is, as seen from the power section. And what is now really important is that this loop formed between each individual half bridge and the capacitors needs to be as small as possible. How do we do that? The switches are here, just right on the heatsink. This very thin white line is all that you have from the ceramics and the MOSFETs. So it's less than 1.5 millimeter high, the whole power system. And right on top of these switches are actually here shown in brown, the capacitors. So basically, the loop shown in red here on the left side is really as small as shown here in the cross section. So we form a lot of small loops between the individual capacitors and the individual switches, plus we have paralleled them massively to minimize the induction in the system, and in that way creating a very small inductance and small switching losses. The second part are the low ohmic losses, and this is easiest to do is make sure that the power routing is as short as possible and the cross section used for that is as large as possible. And on the ceramic system, we use 300 micrometer thick copper passes as wide as possible, and the AC connectors here is actually 2 millimeters wide, so there's a lot of cross section available to actually conduct your current. In that way, the SKAI 3 low voltage generates as little losses as possible in that system. And the good thing for you is you don't have to worry about it because the gate driver is already optimized for the switches used inside. You just take the system as it is, feed in your PWM, and you don't have to worry about switching speed of the devices. That has already been taken care of. So where do we come out? Just to give you some figures, And you see here in blue the efficiency for a system which is running at about roughly 30 kVA output power. So at 100 volt input voltage for the battery, using 150 volt MOSFET, somewhere in the range of 200 to 300 amperes RMS output current, we are well above 98%, almost 99 when we talk about 8 kilohertz operation. At 16 kilohertz, it's still above 98%. A little bit lower because current being much, much higher, but still looking at 30 kVA. If you're using an 48 volt system, we need to double the current to come to the same output power. And here you see, of course, if impact of resistance taking its toll, but we are still above 96% efficiency for the 16 kilohertz operation for most of the time, and 97% roughly for 8 kilohertz. So efficiency extremely high in that system, still at very high output powers. So let me give you a summary. First thing is no stiff joints in the system. So no joints that can break, means high ruggedness and high reliability of the overall design. Plus we use ceramic substrates instead of IMS, and you have more silicon per area, which means a strong paralleling is possible. So we get a lot of current out of a small volume. Plus we use the low RTH, which is given by the ceramic, which again means good cooling, again meaning high output current out of a small volume. Electrically, the small induction loops come to small switching losses, low switching losses, plus low resistance in the power routing means overall system efficiency being extremely high. That brings me almost to the end of my presentation. I want to show you a few pictures now on the SKAI 3 low voltage production line, because what good is a product that cannot be manufactured, right? So the SKAI 3 low voltage has its own production line in Semikron. And this production line is used for the standard design that I showed to you today, but it's also used for customized designs for some specific applications or special projects. So that line is installed now, as you can see here, and there's actually a nice YouTube video. The link is shown here on the bottom right. You can take that later from the PDF and go to the internet and watch that video. It will show you some more details on the production line. We're talking about a semi-automated production concept where we have the critical steps taken over by the machine completely, and some other parts are still done manually where it is safe and more convenient to do so. What we have is a very high level of inline component and process control. So we check every step, where we are, what comes next, and do the parts actually match to each other. So that's what you can see here. For example, a partly assembled SKAI 3 low voltage is checked on the back side by a laser scanner, so the system knows which product is in the line. And here in the box on the right side would be the next part. This part would be checked, and then the system checks, does this part match to the job here waiting? And if it's yes, then you can install it and can proceed. Sometimes very simple solutions are done here. This is a station where a part is manually assembled, and the operator has simply the signal here in red. Do not add the component, check first. This red flag goes away, then you can mount your next part. Also, an important part is the screwing process. So to make sure all the components are screwed together correctly, all the screws are in to the right with the right torque and the right number of rotations, we have decided that this is done by an automated screwing process. As we are using the pressure technology, having the screwing process fully in control is very important. So this is a completely human-free process step here, fully automated separate box. That's it so far from my side. Thank you very much for your attention. Stop. I will give you a short summary. Again, here is the link to the video. Let's have a last summary. So what did I show you today? By adding a controller and software to the SKAI 3 low voltage, you get a complete motor controller system. The mechanical and electrical interface is optimized for easy mechanical and electrical connection. We can use technologies, or we do use technologies from high power modules and use them for a MOSFET inverter, making it extremely rugged and reliable. The electrical design for low induction and low resistance lead us to very high system efficiency. And last but not least, with a dedicated semi-automated production line, we are ready to manufacture the SKAI 3 low voltage in volume quantities. So that's it for now. That's it for today for me. Thank you for joining this webinar. And now I'm waiting for your questions.
Lutz, thank you very much for that very interesting presentation. We have indeed received some questions that we should maybe go through now. Some of these, I guess you have already answered in the presentation. Nevertheless, let's go through it. The first one would be, you mentioned that out of this technology portfolio that Semikron has, the chips are soldered. Why do we not sinter? Because Semikron is also a sintering company, right?
Yes, Semikron is well known for sintering. However, here we decided to use, let's say, cost-optimized solution. So a MOSFET-based inverter is typically used together with air-cooled system, or let's say comparatively weakly cooled systems, which means the temperature cycling and all these effects that go with that are fairly weak. So using soldering and wire bonding as a technology for die attach is perfectly okay.
So designed to fit, designed to cost, I guess. Okay, thank you.
Yes.
You mentioned, or you talked about the commutation. What is actually the commutation inductance of the SKAI 3 low voltage?
Yes, the commutation inductance between the half bridges and the capacitors are, including really the complete loop as installed, is about 2.5 nanohenries only.
Oh, that's really low. There were some questions about the protection functionality. So what protection functionality is actually included in that SKAI 3 low voltage?
Yes. So with a gate driver, we have actually decided to limit the customer as little as necessary. So we only added functionalities that are really needed to protect the system in case of external failures. So we do have a short circuit protection, which kicks in, for example, when you have a short circuit on the outside. So this is a short circuit which is way beyond the current reading of your sensors, but it's still low enough that the chips don't explode. Plus, on the gate driver, we have some error handling functionality, allowing you to switch off the gate driver through a separate path if your microcontroller does not respond, for example.
What about a module temperature measurement?
The module temperature measurement is we have an installed temperature sensor on the ceramic substrate directly, which is fed through the gate driver to the controller. And there's a second temperature sensor on the PCB, which basically measures the temperature under the cover of the inverter. So you have two different temperature signals to monitor your system temperature.
Then there's a question about the connectors that are used to connect the control board to the gate driver. Is that a standard connector, or is that anything very specific that we use there?
The connector between the gate driver and the controller is from the company called Iriso. It's a standard connector and freely available. To make it easy for you, you can get for sample quantities the connectors through Semikron.
Okay, thank you for that. Then another question is the SKAI 3 low voltage customizable in any sense?
Yes, the SKAI 3 low voltage is customizable in actually many directions. As I said, it's designed as a platform for all kinds of customization. But of course, the degree of customization depends strongly on the size of the project. So it can start from a customer-specific cooler, for example. They say this is a small change, but you need for some special reasons. You need a water cooler, you need an air cooler, or some other thickness of the plate or whatever. So that can be easily done. We can also, of course, work with a different kind of cover, and we can adjust the number of switches. All these kind of things are possible, but it's of course always a joint project, and we need to work out what is the optimum then for everyone.
Okay, then maybe one final question. Can you say something about the technology of the DC link capacitors that you use?
The DC link capacitors used in the SKAI 3 low voltage, as we have it right now, as we focus on industry and off-road vehicles, is today just a typical electrolytic capacitor type. Nothing special. It's special. It's a high quality type use with 8,000 hours operating lifetime at 105 degrees C. But it's besides that, it's standard electrolytical technology. But
Okay.
of course, it may be changed to a different type if required. That's one of the options as well.
And then one more question that came just in. Are we using silicon MOSFETs, and would be gallium nitride HEMT an option?
So we are using silicon MOSFETs today as a standard, and for, let's say, to make it cost optimized for the applications which are today using 8 kilohertz, 10 kilohertz, 16 kilohertz, the silicon MOSFET is an option. Gallium nitride HEMT might be something to discuss for, let's say, for the upper voltage range in the future.
Okay, and then the final one. The high current DC and AC connectors, what are they? What do they look like, and what connectors are used there?
Okay, the DC and AC connectors are just designed with for an M8 cable loop. So basically, you have M8 screws sticking out to the top. You put your cable loop with cables 70 square millimeters or more on that system. You put an M8 screw on top, and that's it.
Okay, Lutz, then thank you very much for these question and answers. There's still coming some questions in, which we will then answer by email. In any case, you also see the email address right now again, sky-lowvoltage@semikron.com. You can always use also the webinar at semikron.com email address. I have also released the PDF file now for download. So this is right in the underneath the chat window where you can download the PDF file of that presentation. I hope you enjoyed the presentation and could take away some useful information. We will keep you posted with upcoming webinars. The next one is already scheduled in 2 weeks. The topic will there be energy storage systems. And we would really like to welcome you to this one or the other upcoming webinars next year. See you then. Thank you and bye-bye.